All right, guys, and then here's the questions on that second one that we wanted to go over. Okay, so again, product quotient chain. I look at this one and I see I have multiple functions happening. I have a natural log function, I have a square root function, and then I have this x squared plus 1 function. So I'm going to have to use the chain rule. The derivative of the first function that I see, the outermost function, the derivative of a natural log function is 1 over whatever's inside that natural log. So the derivative of the natural log is 1 divided by the square root of x squared plus 1. Now the derivative of the square root function. The derivative of a square root function is 1 divided by 2 times whatever that radical is, x squared plus 1. Then the derivative of what was inside that radical is 2x. When we multiply fractions, we multiply straight across. So in the numerator, we're going to get 1 times 1 times 2x. So we'll have 2x in the numerator. Divided by, in the denominator, 2, and then this square root times that square root gives me the quantity x squared plus 1. These are going to cancel. I cannot cancel these x's because they're not terms independent of each other. This x squared is connected to this 1 through addition. So I have x divided by x squared plus 1. F, G. We're multiplying those things together. The derivative of an exponential function is the exponential function times the derivative of the exponent. Now this exponent is negative x, so the derivative of that is going to be negative 1 times g, the cosine of 2x, plus e to the negative x times the derivative of cosine. Sine, cosine, minus cosine. The derivative of cosine is minus sine of 2x times 2, because there was a 2x inside that sine. Looking at what these two terms have in common, this term has an e to the negative x. This term has an e to the negative x. This term has a negative 1. This term has a negative 1. So we can factor out a negative 1 e to the negative x. And then I'm left with the cosine of 2x plus 2 times the sine of 2x. Now, this cannot be factored out because it's embedded inside those trig functions. So the only thing I can factor out are those standalone terms. What is this? Negative e to the negative x, cosine 2x plus 2 sine 2x, looks like A. F, G. The derivative of that numerator is 2x. Oh my goodness. Let me see. Come on, Mark, be better. So 2x times the quantity 1 minus x squared minus the quantity 1 plus x squared times the derivative of that denominator, which is going to be negative 2x, divided by that denominator squared, which is 1 minus x squared. In the numerator, we can distribute. So we'll distribute through a 2x. So I have 2x minus 2x cubed. I'm distributing through a negative 2x, and I'm also distributing through a negative 1. So those negatives are going to kind of cancel each other out. So plus 2x minus plus, I just said they're going to cancel out, 2x cubed. These guys end up canceling, and we have 4x in the numerator. natural logs happening all over the place. So there is natural log, there is natural log, there is 5x. So the derivative of a natural log function is 1 over whatever's inside that natural log. And inside that first one is the natural log of 5x. Then the derivative of this natural log function is 1 over 5x, because what's inside that natural log function is 5x. And then the derivative of 5x is 5. These 5's end up canceling, and I get 1 over the natural log of 5x times x. Okay, the derivative of a natural log is 1 over x over 2, and this because it's always 1 over whatever's inside that log. Now, another way to think about 1 over means the reciprocal of. So, what's the reciprocal of x over 2? Y prime is equal to the reciprocal, because 1 divided by a term is the reciprocal. I can't begin to spell that. The reciprocal is 2 over x. And when I have fractions like that, it helps me to visualize it as writing it as the reciprocal rather than 1 over x over 2. And then 2 divided by 4 is a half. This is kind of a sneaky quotient rule because my first function, f, is 3, and my second function is 4 plus x squared. So now when we take the derivative of that, the derivative of 3 is 0 times the quantity 4 plus x squared minus 3 times the derivative of 4 plus x squared is 2x divided by that denominator as a quantity squared. In the numerator, I get 0 minus 6x. So I have negative 6x in the numerator divided by the quantity 4 plus x squared squared. I know I'm probably going to end up running out of space on some of these, but I have to get the table in there. So this is just straight up product rule. So the derivative is going to be the derivative of the first times the second plus the first times the derivative of the second. And if I plug in a 1, h prime of 1 is going to be the derivative of f at 1 times the value of the function of g at 1 plus the value of the function f at 1 plus the derivative of g at 1. And this table gives us all that information. So for this first piece, what is f prime when x is equal to 1? So if I follow over this and I'm looking at x is equal to 1 and I'm looking at the f prime column, the value of f prime at x is equal to 1 is 4. So 4 times, now I'm looking at g of x when x is equal to 1, so 2, plus f at 1 is 6, times g prime of 1 is 5. And I get 8 plus 30, which is equal to 38. Similar to what's happening there. Let me get out of here. Similar to what's happening there, now we're going to be using the quotient rule. And I'm not going to write it all out. I'm going to write it out as h prime of 1. So h prime of 1 is equal to f prime of 1 times g of 1 minus f of 1 times g prime of 1 divided by g of 1 squared. Now I'm going to put those things in where they belong. So f prime of 1, again, using this table, f prime of 1 is 4, g of 1 is 2, minus f of 1 is 6, times g prime of 1 is 5, divided by g of 1 is 2, and we're squaring it. I'm just going to kind of finish this down here, and I'll make more space for that one. So 8 minus 30 divided by 4, negative 22 divided by 4, which I guess you could call negative 11 halves. You can leave it as, it's not a multiple choice, so you can leave it however you want. This is the chain rule. So h prime of x is equal to f prime times g of x times g prime of x. Now h prime of 1 is equal to f prime times g of 1 times g prime of 1. G of 1, if we go to the table, is 2. F prime of 2 is, now I need to use this row, f prime of 2 is 2, times g prime of 1 is 5, so we get 10. Okay, the derivative of a radical is 1 over 2 square roots of the radical times the derivative of what's inside the radical. So h prime of 2 is going to be 1 over 2 times the square root of f of 2 times f prime of 2, which, if we look at what f of 2 is, f of 2 is 9, because it's in this f, and then here's my x value of 2. So I'm looking at 9. 1 over 2 times the square root of 9. So this is 9. The square root of that is 3. 1 over 6 times f prime at 2, which reduces to 1/3. All right, again, we'll probably have to talk about some of these, but let me know if you have any questions.